Okay, so let's take a look at this one here. We have the position is going to be located by -1, +1, so it's going to be right about there. So it's going to be in quadrant 2, and that line, that point, locates that position of -1, +1. Okay, so we have an x and y positioning of that point, and there's also an angular positioning of that same point. Okay, so we can draw here, this is angle theta. It's always measured from 0 degrees. Okay, so it's always measured from that position, and it locates that black dot there. So the quadrant that we're in is quadrant 2. Calculating the radius here, we just use Pythagoras. That's going to be √2. So we end up with square root 2 as our radius. And then once we have that, then we can state our sine, cos, tan, theta. Okay, our sine ratio is going to be opposite or vertical over the radius. Cosine goes with horizontal, so it's going to be -1 over √2, and tan is the slope, so that line has got a negative slope, and it's got a negative slope of 1. Sorry, -1. Okay, so and notice that I haven't used my calculator. I'm using no decimal values here because I'm not translating between angle and ratio. However, this one is kind of special because I think we kind of know, because especially with the symmetry of those two coordinates, we kind of know the angle in here. In fact, we probably know that that angle in here is 45 degrees. So if I were to actually work out the positioning, we could use our calculator, and our calculator would give us, the positioning as well. But just by looking at that angle is going to be, looks like 135 degrees, and we don't need a calculator. So I'm just going to write here, no calculator needed. And when we don't need to involve a calculator, we want to try to do it in that way. So there's no calculator needed here, and we'll get into this, but this is a special angle. So we don't need a calculator here because this is an angle that has symmetry, and this is one of very few angles that we can do without a calculator.